Welcome to this video looking at how we can measure the rate of reaction. In this video we are going to look at how the rate of reaction is affected by reactant volume. So let's have a quick look at some of the equipment we can use. So flasks are used to carry out reactions in. Gas syringes are used to measure the amount of gas produced very precisely. A stopwatch is used to time things in seconds. A balance measures the mass of reactants in grams or milligrams. A measuring cylinder is used to measure the amount of a liquid or a gas in milliliters. And a water bath is used to invert a measuring cylinder into, and then you fill it with water, and then you can measure the amount of gas produced by seeing how much water has been displaced. Thermometers are used to measure the temperature in degrees centigrade, and beakers are generally used to carry out reactions in, store things in, or mix or heat liquids in. So when thinking about practicals, there are several keywords that we need to remember. So a control variable is any variable which does not change during the experiment. The dependent variable is the variable that we're going to measure and responds to the independent variable. A hypothesis is a prediction on whether the independent variable will have an effect on the dependent variable. An independent variable is a variable that we are changing. An anomaly is a result that does not fit the pattern. A correlation is the relationship between two variables. An error is a measure of the difference between the measured and the calculated value and the true value. And precision and accuracy are often used interchangeably, but in science they have different meanings. So measurements that are close to the known value are said to be accurate, whereas measurements that are close to each other are said to be precise. Now that we've had a look at different variables and things, we can go and look at how we carry out the investigation. So remember, when you put a method together, it needs to be detailed. In this investigation, we are going to look at how changing the volume of a reactant affects the rate of reaction. So some of the equipment is shown below. So we're going to use different amounts of acids measured out in a measuring cylinder, and we are going to react it with sodium thiosulfate this time and measure the amount of time it takes in order for the sodium thiosulfate to become cloudy. So the faster it becomes cloudy, the faster the rate of reaction will be. So using the measuring cylinder, add 50 centimeter cubed of dilute sodium thiosulfate solution to a conical flask. Then you're going to place the conical flask onto a piece of paper with a black cross drawn on it. Using a different measuring cylinder, add 5 centimeter cubed of dilute hydrochloric acid to the conical flask. Immediately swirl the flask to mix its contents and start the stopwatch. Look down through the reaction mixture. When the cross can no longer be seen, record the time on the stopwatch. Then repeat steps 1 to 5 with different volumes of hydrochloric acid. After that, repeat the whole thing 3 times, so it gives you 3 sets of results to go and work out an average for each volume of hydrochloric acid added. So now that we've looked at how to carry out the investigation, there are just a few last things to think about. So there are a few questions that you should ask yourself when completing your method. So what thing should you do first? Is there something confusing you? And if there is, where could you look for some help? Could you explain your method to somebody else? So does it make sense? Could you have used more scientific terms within your method? And if you need help, do you know where to look for it? Have you double checked what you need to include? And have you had a think through how you could possibly make your method better? Right, that's it for now. Thanks for watching, and I hope this has been helpful.